This is the homework helper for Chapter 11, Section 5 in the 7th grade workbook, Making Predictions. So numbers 1 through 4 all have the same directions. We're to make a prediction based on experimental probability. So let's look at number 2. Frederica can make 65% of her shots from the free throw line. If she shoots 75 times, how many shots can she expect to go in? Well, you see the key word there, the operative word is of. You know that of means multiply. So she's going to make 65% of her shots, and she's making 75 of those shots. All we have to do here to find the solution is to multiply together 65% and 75. 65% as a decimal is 0.65, so I'm going to do 0.65 times 75. And when I do 0.65 times 75, the result is 48.75. Now, obviously, she can't make 48.75 shots. That answer makes no sense. So we're going to round accordingly and say that she's going to expect to get around 49 shots. Let's try that again on number 4. A survey shows that 67% of peanut butter lovers prefer chunky style. Out of 850 people surveyed, how many can be predicted to say that they prefer chunky style peanut butter? Well, again, 67% of those people like the chunky. So here, we're going to multiply together 67% and that number, which happens to be 850 in this question. So I'm going to do 0.67 times 850. Again, 0.67 is 67% as a decimal, found by moving the decimal 2 times to the left and removing the percent sign. So when I do 0.67 times 850, the result is 569.5. Well, obviously, we can't have 569.5 people, so we're going to round here and say that about 570 people prefer the chunky style peanut butter. All right, let's go ahead and take a look at the next set of questions here, 5 through 8. Now we're going to make a prediction based on theoretical probability, which means we're probably going to have to derive some probabilities before we can make the conclusions that we were making in 2 and 4. Number 6 says, Jenna flips 2 pennies 105 times. How many times can she expect both coins to come up heads? Well, as you recall from a question we did yesterday, we did a tree diagram that looks much like this, but we'll remake it quickly. We're looking for the options that show heads and heads. So, on coin 1, I could flip heads or tails. And then when I go to flip coin 2, I could also land heads or tails. If I land heads on the first one, I could land heads or tails. If I land tails on the first one, I could land heads or tails. Well, of the 4 options that are presented, heads and heads, heads and tails, tails and heads and tails and tails, only one of them is heads and heads. So there's a 1 out of 4 chance of me landing heads and heads. Now we're going to try this instead of just 4 times and expect it to happen once. We're going to try this 105 times. So you've got some options here. You can take 1/4 and multiply it by 105, or you can take and write this as a proportion and solve the proportion. What the proportion would say is if it happens 1 time out of 4 total trials, what would happen if I tried it 105 total times? Well, the top number is what I don't know here, how many times it would happen. Solve the resulting proportion using the method of your choosing. We can cross multiply, which is probably what I would do, or if there's a number we can multiply by easily to get me from one side to the other that we can see, we can use that. I'm not seeing what I'm going to multiply 4 by to get to 105, so I'm going to cross multiply. 4 times x is going to give me 4x, and 1 times 105 is going to give me 105. So what number do I multiply by 4 to get to 105? Well, if we do 105 divided by 4, we'll find the solution. 105 divided by 4 is 26.25. Well, obviously, it's not going to land heads and heads 26.25 times, so we're going to say approximately 27 times. Number 8, Ron draws 16 cards from a standard deck of 52. The deck is made up of equal numbers of 4 suits, clubs, diamonds, hearts, and spades. How many of the cards drawn can Ron expect to be spades? Alright, so we know since there's 4 different types, one of every 4 would have to be of the spade set. So there's 1 out of 4 chance we're going to get a spade. We can inflate that number and talk about the whole deck here because exactly a fourth of the cards are spades. If we take 52 and divide it by 4, all right, we're going to get 13. So that means 13 of the 52 total cards are spades here, but if we reduce the fraction 13 out of 52, no surprise, we would come all the way down to 1/4. So we're really not going to mess with it. So we know one card is going to be a spade, theoretically, if I pick 4, because there's 4 different suits in the deck. So now what they're saying here is he's going to try this drawing 16 cards, 16 total cards. How many cards will be spades? So I'm writing my proportion. Notice the totals are both in the denominator. The number of spades that we're going to get is what's going to be in the numerator. Since we don't know how many spades we're going to get when we try this with 16 draws, that's why I've written X there. That's, of course, what a variable represents, what we don't know. Solve the proportion. Well, to change 4 into 16, I'm multiplying by 4. So I'm going to do the same thing in the numerator, multiply by 4. 1 times 4 is 4, so X equals 4, which means he's going to expect to pull 4 spades. All right, finally we'll take a look at number 10. Number 10 says ABC Airlines had delays on 18 of 126 recent flights. DEF had delays 13% of the time. Which airline would you expect to provide more reliable service and why? So, obviously, we can compare these, but we have to compare them in the same form. So the trick here is write these all as fractions or all as percents to compare them, because it'll be much easier to compare them when they're in the same form. 13% isn't really a problem for me, but we can go ahead and change that to its decimal form because the fraction that I'm going to work on with ABC is going to go to decimal real quick. So we know that's going to be the same as 0.13. Again, we're moving the decimal 2 times to the left and dropping the percent sign. So what it says here is that ABC has delays 18 out of 126 times. So if we're saying it's 18 out of 126 is when they have delays, of course, to change that to a decimal, we're going to divide. 18 divided by 126. And that's approximately 0.14285. Well, so this is 0.13, this is 0.14, and then some. Obviously, this one is bigger. So when we're asking which airline has more delays, ABC has more delays. Which one has more reliable service? That means DEF is more reliable because they have less flights that are leaving late.